This video is just to save a bit of time in class. I'm just going to go through some of the problems that occurred across the class in our nasty quiz. And the first of those was converting units. Now, we were pretty good at converting units, except when it came to mass. Okay, we forgot a very important thing about mass, and we forgot that the standard unit of mass is actually the kilogram, which is a real pain because the standard unit has a kilo in front of it, where most other standard units don't have a prefix like that. Most other standard units are things like seconds or meters. But unfortunately, the standard unit is not the gram. The standard unit is the kilogram. So when we convert to standard units, we've got to remember to convert to kilograms at the end. So if we look at this here, convert 2 grams into standard units, we want to convert 2 grams into kilograms. And we don't want to change the number, we just want to change it to kilograms. And what we're doing is adding a k in here. And don't forget that adding a k is like timesing by 1,000. So if we're adding 1,000 in there, to keep the number the same, we've also got to divide by 1,000. So to convert 2 grams into kilograms, I just divide it by k. Okay, 2 grams is 2 on a kilograms, which is 2 by 10 to the minus 3 kilograms. And that's how you convert units. Don't forget to divide by that extra unit you're adding in. Another question here, convert 55 micrograms into standard units. Well, straight away, the first thing we do, part 1, we want to convert this into grams first to make our lives easier. All we're going to do is replace the micro with by 10 to the minus 6. So that's the same as 55 times 10 to the minus 6 grams. Then we want to convert that to kilograms. So once again, all we've got to do now is 55 by 10 to the minus 6 on k kilograms, which will give me 55 by 10 to the minus 9 kilograms. And don't forget k just means 10 to the 3. So all I'm doing is dividing that number by 1,000 to convert from grams into kilograms. Okay, let's move on. There's one more style of converting units which also cause some problems, and that's converting ratio units. When you're converting ratio units, not just converting 1 unit, you're actually converting 2 units at the same time. In this case, kilometers to meters and hours into seconds, and one's over the top of the other. Now, I was going to do an example, and hopefully by example this will make a bit of sense to you. If I was converting 35 kilometers per hour into meters per second, I've got to imagine that as I'm trying to convert 35 kilometers over 1 hour into meters per second. And if I think about it this way, that means I'm just doing 2 simple things. I'm just converting 35 kilometers into meters and 1 hour into seconds and leaving it at that. So 35 kilometers into meters, all I've got to do is replace the k in kilo, so that's just 35,000 meters. And converting 1 hour into seconds, well, I know an hour, there's 60 minutes in an hour, 60 seconds in a minute, seconds, so that's just going to become 35,000 meters divided by 3,600 seconds, or that's exactly the same obviously as 35,000 on 3,600 meters per second. And if I was smart enough to bring my calculator with me, I did that sum, but I'm assuming that you can actually put that in your calculator and figure out what it's supposed to be. So whenever you get these ratio units, just treat it as 2 separate fractions. Treat the top line and the bottom line, and then do the sums. We'll do one more example, kilonewtons per microgram into newtons per kilogram. Let's just say I had 40 kilonewtons per microgram. Once again, I just treat it as a fraction. So that's the same as 40 kilonewtons over 1 microgram. It's 40 kilonewtons per microgram. And I want to convert that to newtons per kilogram. First thing I've got to do is replace the kilo and the micro. So that's just going to become 40,000 newtons over 1 times 10 to the minus 6 grams. I've got the newtons right, now I've just got to convert the grams into kilograms. So all I'm going to be doing is dividing by 1,000 again. So that's just going to become 40,000 newtons all over 1 times 10 to the minus 6 all over 10 to the 3, because remember a kilo is 10 to the 3 kilograms. And we just clarify that a little bit more. Sorry about the lack of calculator. That's going to be 40,000 all over 1 times 10 to the minus 9 newtons per kilogram. And if you just remember to treat these ratio fractions as look at the top line, look at the bottom line, convert them separately, then obviously use the calculator you brought with you to figure out the final number. So break it down, take your time, don't try and rush, don't try and do all the steps at once. Some people can, and that's great, but you're more likely to make mistakes. You've got plenty of time, break it down, do it properly, don't make mistakes. The last thing I want to look at is rearranging equations. Now, we did really well at some of them. I think number 2 we did really well at on this little list, or B in your test, but some we didn't do so good at. And I think A was probably the worst done of all, because I think people see such a simple equation and jump into it and do it without thinking. It's very important you think and take things slow and do things methodically in physics. So we've got Z equals TA. And we want to make T the subject. Now, I think what confused people is we usually write equations with T equals blah, 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 blah if we're making T the subject. But it doesn't matter what side of the equation T's on, okay? If you've got blah, 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 blah equals T, you've still rearranged the equation to make T the subject. Just you've got T on this side rather than that side. It doesn't matter what side of the equation it's written on, okay? It's usual to write T on this side, but if you get T on its own on this side, that's perfectly fine. So why don't we try and keep T on the right? Don't even worry about getting T on the left. We've got TA equals Z. Well, how am I going to get rid of that? I want to divide by A to get rid of the A. But I've got to divide by A on both sides. So therefore, Z over A equals T. And look, that's perfect. You can stop there. But if you really don't like the fact that T's on the right-hand side, not the left-hand side, all you got to do is just write this on the next line. T equals Z over A. But really, you could stop there. A lot of people just went straight away and did something really bizarre. They either said T equals A over Z or T equals ZA without thinking. Think, stop, slow down, do things properly. Let's look at number 2 up here. A similar sort of thing. W equals F plus G in brackets all over T. Now I want to get T on its own. Now right now T is trapped down the bottom here on the right hand side. If I just times both sides by T, I can get T off the bottom. And that gives me TW equals F plus G. And now I also want to get rid of W. I can divide both sides by W, which means that T equals F plus G all over W. Once again, some people may know that you can straight away just swap those two places, and that's definitely what you can do, but there's no point in rushing. Take your time and get it right. Let's look at number 3 as well. See if we can fit number 3 onto this page. Number 3 is G equals R outside of A minus 1 on T. Now this 1 on T is trapped in a bracket with the A, so the first thing I do is just get rid of the R at the front. I'm going to divide both sides by R. So G on R equals A minus 1 on T. Now this, I think, caused some problems, the fact that the T was the negative side on this. So why don't we just add 1 on T to both sides? I was going to add 1 on T, so plus 1 on T to both sides, plus 1 on T. So I'm going to get 1 on T plus G on R equals A. I just want to get that T on the left-hand side. I must admit, I like having T on the left-hand side. That's how my brain works. So now T's on the left-hand side. I'm feeling slightly better about it. But I want to get rid of this G on R. So why don't we take G on R from both sides. And we'll take this back up here. So now we're going to have 1 on T equals A minus G over R. We're almost there. Only thing is, we've got 1 on T, we want T. Anytime you've got the thing you're looking for on the bottom of a fraction equal, you can just, what we say, invert both sides. We just invert both sides of the equation. So we're just going to write, rather than 1 on T, we're going to write T. But if we're going to invert this side of the equation as well, we're going to put 1 on that whole side of the equation. A minus G over R. That's all we've got to do. Now, these shouldn't be too tricky. Okay, up to D shouldn't have been too challenging. E definitely is a little bit more challenging than the rest. Not many people, I don't think anyone actually got E completely right. Some people were so close but forgot the negative sign halfway through. That actually is a cubed just there if you're not sure. Okay, so don't forget that. I think it'd be really good if you'd all go back and try C and E and bring in a new answer for our first physics lesson next week. Obviously you don't get this video in time, I understand, but it's really good training, really good practice. We need to get better at this because we need to be able to solve particularly ones like this really quickly. This, you'll never get anything as complicated as this, but all I'm giving you these questions is if you can solve a question as hard as this, nothing in the physics course is going to challenge you. So you definitely need to be able to solve A, B, C and D. Solving E just means you really understand your rearranging equations. So please, if you can, C and E, a new answer by next week. And if any questions anytime, don't hesitate to email.